Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this unique BST problem of the GFG. Okay, so in this problem what we have to given, we are given with the integer n and we have to find how many structurally unique binary search tree, unique BST we can form which store value from 1 to n. Okay, like for value n is equal to 2 means of value of nodes of given value 1 and 2 we can form binary tree these two 1 2 and these two 1. Okay, so total number of binary tree we can form is equal to 2. For n is equal to 3 we can form total number of 5 trees. You can see here 1 3 2 3 2 1 3 1 2 2 1 3 and 1 2 3. Okay, these are 5 different combinations we can form using n is equal to 3. Okay, so output we should output 5. So now how we will do it? So and we have to return our answer by doing it modulo with 10 raised to the power 9 plus 7. It is 1 actually, 1 in 9 plus 7. Okay, 10 in 9 actually not, it is just written mistake. Okay, so guys, how we will do it? Suppose if we have n is equal to 5. Suppose just I write it like this, then how many we can form? Nee. Suppose initially suppose we have n is equal to 3. Okay, and you first of all you should know like this, it is n and it is BST, count of BST. Okay, for n is equal to 0 how many BSTs are possible? As you know, our values will start from 1 to that integer, so we have nodes, we have 0 nodes. So binary search tree possible count is equal to 1. A tree whose root node is equal to null, which contain 0 number of nodes. Okay, if our n is equal to 1, then our binary tree is equal to 1, only the root node. If our n is equal to 2, like suppose 1 comma 2, it is our n. Okay, we will see in it also the same example, like, so don't need to check it exclusively. Okay, so here binary tree possible 1 and 2. It is binary search tree. Okay, so 2 is greater than 1, so it will also always come to its right side. Okay, and if one second binary tree we can form is as 2 1 in on left side. Okay, so for 1 and 2 we can form these two binary tree different. Okay, so total number we can form is equal to 2. So if n is equal to 3, okay, so n is equal to 3, now we have nodes is equal to 1 2 and 3. So how we find how many total different binary tree we can form? So first of all what we have to do, we have to choose the center node, that is root node. Okay, here three possible combination can be: one, root node is equal to 1, here is something on left, something on right, something on left, something on right, and 3 as a root node, something on left and something on right. Okay, so first of all, so our total number of nodes possible we can make by choosing n is equal to 3 will be is equal to sum of these all three. Okay, when 1 is our root, 2 is our root, plus when 3 is our root. Okay, so we have to find out, basically this problem is now reduced to, we have to find out how many total number of BST we can form as 1 is our center and remaining 2 as our nodes. This is same, this is same, here root nodes are same. So first of all we will find this. How can we find this? Okay, so suppose this is our root node. Now we have to put 2 and 3. Now you know in our left side we don't have any node that we can put on it left side, so here node number is equal to 0. Okay, or we just value. Okay, so 2 and 3 will come to this. So one way of forming this, 2 come to is right, 3 come to right of 2. Okay, and the second way is form is equal to, both will come to its right side. Okay, so first of all we will make 2 as a root node of its right side. Now 3 will be the root node of its right side. Okay, now how, where we can put out 2, where we can put out 2, here, just a minute. So here we can put out 2. So total number of binary tree possible are is equal to 2. Okay, is equal to 2 when 1 is our node. Okay, Or we can also say that we are forming our binary tree count as 1. Here total number of nodes in our left side is equal to 0. Total number of nodes in our right side is equal to 2, 2 and 3. Okay, so total number of binary tree can be possible as when 1 is equal to root node is equal to sum means the total count of 0 into it is multiply. Okay, it is multiply into count of 2. What is this count of 0 and 2? Count of 0 and 2 is the number of arrangement we can make if we have is number of nodes. If we have 0 number of nodes, if we have 0 then we have 1, if we have 2 then we have 2. Okay, so here count 0 into count 2 is equal to 1 into 2. So total number of formation with 1 as a root node is equal to 2. So here 2 will come. Okay, now we have to check for, we just erase this all. Okay, I will just erase it. Just give me some time. Yeah, okay. Okay, so we have to find out for this. If 2 is our root node, then we have two left node, 1 and 3. Okay, so we can only put 1 in our left side only. Okay, we can put 3 to our right side only. So total number of tree can be formed is equal to 1. Okay, and we can also found this total number of nodes in left side is equal to 1. Total number of nodes in right side is equal to 1. Okay, so count 1 into count 1. Okay, so one count of 1. What is count of 1? Count of 1 is equal to 1. Okay, so here you can say 1 into 1. 1 into 1, is equal to 1. Okay, so you can see here 1 will come. Similarly, we will find out for this 3 as a root node, its left and its right. In right side we don't have any node which has value greater than 3, so in right side we have 0 nodes, but in left side we have 2 nodes, 2 and 1, and the number of arrangement, sorry, we have 2 nodes. Okay, we have 2 nodes, so number of arrangement is equal to C0, C2 into C0. C2 is equal to 2, C0 is equal to 1, so it is multiply. Okay, it is multiply is equal to 1, so it is equal to 2. Okay, it is 2. So number of arrangement when our nodes is equal to 3, it is equal to 5. Okay, 2 plus 1 plus 1, 2 is equal to 5. 2 plus 1 is equal to 3 plus 2 is equal to 5. Similarly, if we have number of nodes is equal to 4, then we have root node as 1, 2, node 2, root node as 3, and root node as 4. When 1 is our root node, in our left we have 0 element, 0 node. In our right we have 3 nodes. When 2 is our root node, in left we have 1, and in right we have 2. In 3 our left contain 2 nodes, our right will contain 1 node. In 4 our left will contain 3 node, our right will contain 0 nodes. Okay, so multiplication of suppose this is our vector known as dp. Okay, so dp0 into dp3, 1 into 5, it is equal to 5, plus plus dp1 into 2, dp1 into 2 is equal to 2. Same here, dp2 into 1 again 2, dp3 into dp0 again 5. Okay, because 5 into 1 is equal to 5. Okay, so 5 plus 2, 5 plus 2 is equal to 7, plus 2 is equal to 9, plus 5 is equal to 14. Okay, so when we have n is equal to 4, we have n is equal to 4, total number of nodes we can form is equal to 14. Okay, I can also show you. When we have n is equal to 4, we have answer is equal to 14. Okay, and for n is equal to 2, so answer is equal to 2. For n is equal to 3, answer is equal to 5. Similarly, we can calculate for 5, 6, 7 and till 1000. Okay, and this is n square approach. Okay, because for each n, and now how we are doing it, I am telling you how it is equal to n square. Okay, so first of all we will take mode. as you can see here it is written. Okay, it is 1 e9, not 10 e9. Okay, so if we have n is equal to 0 or 1, then we just return 1. Okay, as well we will take a vector of long type of size n plus 1 and initialize it with 0 and put out dp0 and 1 is equal to 1. Then for I is equal to 2 to n we will turn a loop. Okay, and this loop will work according, it's suppose that we have node I. Okay, we have maximum node is equal to I, so we have the maximum number of root node we can have is from 1 to I. Okay, like 1 2 3 4 5. If suppose your n is equal to 15, like if we have to calculate for n is equal to 15, okay, then we will calculate this then this, and suppose we are at 4. Okay, then we will, our j will and for 1 to 4. Okay, our I is equal to 4 at this moment, and initially j is equal to this, then j is equal to 2, then j is equal to 3, then j is equal to 4. Okay, in next step I is equal to 5, so our j will work accordingly. Similarly our I will increase according to n. Okay, and what our dpi will store, dpi plus is equal to number of left node, j minus 1 is equal to left node, number of nodes in the right direction. Okay, number of nodes on the right side, modulo mode, and again modulo mode. Okay, so now what I can do, you can see I just submit it. Now you can see all the test cases, all the 21 test cases pass out. Time taken is also very 0.1, very low. So guys, I hope you understand it. I explain it very well, and if still you have any doubt, then just comment out. I will try my best to explain you, and you can check out my channel for GFG and lead code solutions and others many coding solution also. Hope you like the video. So please subscribe the channel, like the video, and stay tuned. Thank you guys.